and you're going to actually use them to solve something. Before, you could change logarithms that we're adding. Sometimes you solve some equations, but now you're really gonna apply everything. So what do you do? What would you do, or how would you solve this?
One squared raised by 2 equals
So smart. You take the base to the exponent, and voila, that equals x, right? What did you use to solve this? The definition of logarithm, right? You went backwards, correct? Okay, let's try another one. Just to show you that you already have what you need. You just need to go into that file inside your head, get the mouse running, coming back, and here I got the card. Here it is, this is what you do, okay? Let's try the mouse again. What do you do? What do you think you do? Look, so you apply logarithm on both sides, right? So that means logarithm, base 10 it's already here, so I'm not going to put it, of
8
equals,
-2x plus 2.
and guess what? What do you do here?
You change 8 to 2.
You use the calculator, you find out the logarithm of 8, which is, see, it's a number, it's a number.
0.90.
Right? And then it becomes easy. But miss, it's got a decimal. So, you're old enough to deal with decimals, right? You're not scared by decimals anymore, correct? You know that the world is made of decimals and not exact numbers.
So it's gonna be 90.31. No, never mind.
Because you're trying to leave x by itself. That is the point, right? That's always been the point for the past 40 years, is to leave x by itself so you can find out how much it is. Another one? Check this one out. This is kind of obvious after we just did this one, but we'll try it again. Now we got base E. Ooh. What do we do?
We do this same as before. You do 5 of log E of 5 equals minus.
What is log E? What if it's logarithm base E? It has its own name. It's not an I. So minus 2x plus 3 equals natural logarithm of 5. Do you know how that happened? Yeah? Because you put a natural logarithm on both sides. And this brings us down, okay? And now what? It's not in, it's natural logarithm.
Okay, natural logarithm is the same as
naturale.
Yeah,
Latin.
natural logarithm is the same as that thing that looks like an E.
It's not an E, it's an L.
No, that's an L.
This is an L. Logaritmo.
No, but logarithm is the one from behind.
Logarithm base E has its own name.
You say base E. You say
Natural logarithm. So instead of writing all of this, where you don't like writing so much, we write LN. It's not an I, it's an L.
But I mean the one that looks like an I. I mean an I. Yes. No, not that one. The one beside it.
Next to it.
The
Next to it.
The E.
The E.
What about the E?
What about it?
How do you call it?
E.
Okay, after that very interesting discussion, that's gonna get like so many hits on YouTube.
Like
Okay, this one's a little bit more interesting and a little bit weirder. What are we gonna do? What do we do?
You do 5 times 6, and in the other side 2x minus 1 times x minus 2. Right?
What do all of these have in common to be able to solve them if you're trying to bring the exponent down?
Natural.
Logarithm. You use logarithm.
2x minus 1 divided by x minus 2.
No, it's a logarithm 6, 5? No. Logarithm 5.
Times 6
Equals?
Logarithm
of
6.
6 minus x minus 2.
Logarithm?
6x minus.
No, I'm doing something wrong.
Wouldn't it be logarithm 5 in x minus 2
Yes.
and logarithm 6?
Yes.
That's called minus.
Logarithm
6.
No, yeah.
5
I can.
2x minus 1 equals logarithm 6 x minus 2. There we go. And now what? Because we're using the same base for both of them. Now what?
10.
How do we need to get these down. What do we do?
And to the
You
power.
divide in the other side.
No.
Log of 5.
No.
Divided.
If this is raising,
Root.
You would
Multiplying.
No, let's cut it out.
what?
Multiplying.
Multiplying. So where do we multiply? So we bring it
Log
down.
6 times 5.
2x minus 1,
Logarithm 5.
logarithm 5. Logarithm of 5. X minus 2,
Oh.
logarithm of 6.
And why do we put logarithm on both sides?
So that we can bring this down. If we don't put logarithm, there's no way of bringing this down. It's up there as an exponent, and if it's an exponent, you can't really touch it because it's something that's being multiplied by itself this amount of times. What does that even, how does that even register in your head? So the only way to get that down is by using logarithm, which is the whole point of logarithms. Look at it this way, and I'm glad you asked. When you have an addition, the inverse is subtraction, right? When you have multiplication, the inverse is division. When you have raising or an exponent, the inverse is root. But in all of these cases, the variable is underneath. This is the exponent, let's say. But what happens when the variable is the exponent? You have exponent here. The only way to bring it down is logarithm. This is the inverse of the variable in the exponent. It's like the last level of the operations, if you want to look at it that way, okay? So does that make sense? This one here, you have x squared. So how do you get rid of it? Well, you square root. But this one here, you have 2 to the x. How do you get to that x? Because it's the exponent, it's one more level up there. Logarithm. Okay? So that's why that's the only thing we can use here is logarithms to get this down here. Once we have this, what's the logarithm of 5?
It's
0.69.
Again, those decimals. Kidding. Okay, equals, and this equals?
Log of 6 is
0.71.
71.
78.
21. How much you?
Doesn't matter.
Guys, look at the book.
Okay, so you have this,
Never mind.
and you know how to do this, right? Then you just multiply side by next. So we go to this?
Yeah.
Pretty simple, right?